zoom in here and look at each of those divisions. So we'll start by looking at the sympathetic system, and then we'll move on to the parasympathetic system. So we said that the preganglionic neurons arise from the thoracolumbar region of the spinal cord. And when we say thoracolumbar, we mean the thoracic spinal nerves, which are T1 to T12, and then the first two of the lumbar spinal nerves, so L1 to L2. So T1 to L2 is controlling our sympathetic division. And they're coming specifically from the lateral horn for the most part, and then a few come from the intermediolateral cell column. Okay, this is not as important as understanding the lateral horn. This is where most of those fibers arise from. And so let's kind of distinguish here the anatomy of these neurons. So the neuron that's coming from the spinal cord, T1 to L2, out to the sympathetic chain, this is the preganglionic neuron, that first neuron, is a much shorter neuron in the sympathetic nervous system. All right, I say that again. So the first neuron, the preganglionic neuron, going from the spinal cord out to the sympathetic chain is a shorter neuron because the sympathetic chain is right next to the spinal cord, okay? The second neuron, the postganglionic neuron that goes from the sympathetic chain out to these various organs is a much longer neuron. Okay, this has much of a longer distance to travel. It's going to go out to the eyes, to the lungs, to the heart, and all of these other organs. And that is going to be a further distance to travel, and hence we're going to have a longer postganglionic neuron. And then the collection of these ganglia, I keep reiterating this, is what forms the sympathetic chain. Okay. Now, among the sympathetic nervous system, we have three methods of communication, okay? Really, really important. Three modes of communication from the spinal cord to those effector tissues. So most of the fibers are going to follow that first rule that I talked about. They're going to go from the spinal cord to the sympathetic chain and then out to the effector tissues. But there are also two alternate routes of communication, and those are the two routes that I'll talk about here. The first alternate route is if they synapse onto a collateral ganglia. So this is a ganglia that is not a part of the sympathetic chain. I keep jumping back to this image here. So we can see that some of these fibers go directly to the sympathetic chain, but then some of the fibers go to a ganglia that is not a part of the sympathetic chain. Here we go, 1, 2, 3. These are what we call collateral ganglia. And they go from the spinal cord to these collateral ganglia and then out to the effector tissues. And so that's the second route of communicating to these effector tissues. The third route of communication is using the adrenal medulla. So the adrenal glands are some of our endocrine glands. They're paired. They're located atop our kidneys bilaterally. So they're really important in their involvement in sodium and water balance, but they also have an area that is important with the sympathetic nervous system as well. And that is specifically the adrenal cortex, okay? The adrenal medulla, I'm sorry. So the cortex is involved with salt and water balance, and then the medulla is involved with the sympathetic innervation. So basically we have our preganglionic neuron synapsing onto the adrenal medulla, and the cells located here are called chromaffin cells. And then those chromaffin cells will release different types of hormones, right? Epinephrine, norepinephrine, and dopamine. And so in this way, the chromaffin cells of the adrenal medulla are pretty much acting like postganglionic neurons. They're relaying that communication from the preganglionic neuron that's synapsing in out to the effector tissues, but they're using hormones instead of actual neurotransmitters, okay? And so in this way, we can pretty much compare a chromaffin cell to a postganglionic neuron. In fact, a lot of scientists have proven that if you take a chromaffin cell and you put it in the correct medium, it will actually begin to grow axons, and it is pretty much a neural cell at its origin, and it behaves just like a postganglionic neuron. It's going to release its hormones into the blood, which are 80% epinephrine, 20% norepinephrine, and then a very small amount of dopamine. And what this hormone does when it gets into the blood is that it's going to flood the system. It's going to go to all of those various organs that I talked about, the heart, the lungs, the eyes, the genitalia, etc. And it is going to mimic the response of a postganglionic neuron synapsing onto these effector tissues, okay? So this is a third method of communication for the sympathetic nervous system. So really important to understand that we've got 3 routes of communication for our sympathetic fibers. We've got the traditional route, which goes from spinal cord to sympathetic chain to our effector tissues. We've got a second route that goes from spinal cord to a collateral ganglia that is not a part of the sympathetic chain, then to our effector tissues. And then we've got preganglionic neurons that synapse onto the adrenal medulla chromaffin cells. And then those chromaffin cells release their hormones into the blood that circulates and goes to our effector tissues. Now, the whole reason that the sympathetic division has this route, this third route specifically, is to bring about a rapid response as a part of the sympathetic system. So think about being chased by a threat, right? Think about your fight or flight response. You really don't want that one-to-one communication that you would otherwise have if you relied purely on the first 2 methods of communication. You want a rapid, widespread response to generate that fight or flight mechanism really, really quickly. And that is what the adrenal medulla, that third route of communication, is helping to facilitate. Okay, that rapid, widespread flooding the system with epinephrine, which can help to help you run away from a threat, use your skeletal muscles, and fight or flight or freeze, okay? All right. Okay, so what we're seeing here are those 3 routes again. So just kind of summarizing those 3 routes, right? From sympathetic chain, from a collateral ganglia, or from the adrenal medulla chromaffin cell. Okay, let's look a little bit more at the anatomy of the sympathetic nervous system. And here I'm going to try to illustrate how the fibers change and how we have different routes or different names for the nerve as it goes in different routes or different directions. Okay. Any questions? Okay, we're doing good. All right. So let's start off by, try to move this out. Once again, looking at this cross section of the spinal cord here, and looking at our dorsal horn, lateral horn, and ventral horn. Okay. And so let's just label these out here. So we've got the dorsal horn, the ventral horn, and then the lateral horn. Now, our fibers that arise from the lateral horn, right? They're coming from the lateral horn here of the spinal cord. They're going to go through the ventral root, and then they're going to enter the spinal nerve, okay? So we want to point out that we have, let's change this here. We have our ventral root, which is where these fibers leave the spinal cord. So I'll make a note here. This is the ventral root of the spinal cord. So there's no lateral root. So it either has to leave via the ventral root or the dorsal root. So it's going to do so via the ventral root, but understand that it's coming from the lateral horn. And it's going to enter that spinal nerve. Okay. And then, as we mentioned, it's going to synapse here at a ganglia. Now, when it leaves the ventral root, it is myelinated. And so we're gonna call this part, this preganglionic neuron, a myelinated or a white ramus fiber. Okay. So this is myelinated or white ramus fiber. And then it's going to join this ganglia. Remember, we said that this synapse connection here is our ganglia. Let's also make a distinction of central nervous system versus peripheral nervous system. So that's our first preganglionic neuron. Let's make a note here, just so that we understand that this is that first neuron. And it's going to join that synapse. Now, when it leaves the synapse, it's going to re-enter the spinal nerve, but here it's going to be unmyelinated at this point, okay? So as it travels from the synapse and back out to its effector tissues, it has changed from a myelinated neuron to an unmyelinated neuron. And here we call it a gray ramus fiber. All right, so at this point, it is now unmyelinated. And we call it a gray ramus fiber. And this is that second neuron, the postganglionic neuron. Okay. Right, and then we get out here to our various effector tissues. Okay, so the important point that I want to stress here is that the first part of this neuron is myelinated. Okay, as it leaves the lateral horn, it uses the ventral root of the spinal cord to exit, and it is myelinated here. We're going to call it a white ramus fiber. And then it's going to synapse on this ganglia, and then it's going to re-enter the spinal nerve, but it's doing so as an unmyelinated or a gray ramus fiber as it makes its way out to those effector tissues. Okay. All right, so that's the second point that I want to kind of point out about how these fibers communicate. And this should be a connection from when we spoke about gray ramus and white ramus last time. We talked about the different areas of the brain, right? The gray fibers pretty much were unmyelinated. And because myelin is mostly fat, it appears white. And so we have this white ramus versus gray ramus when we have myelination versus unmyelination. All right, so let's continue on here. Okay, so this is really just depicting that what we just drew. So we've got our preganglionic neuron exiting via the ventral root, right? So it's going to use the ventral root as a means to get into the spinal nerve, but remember, it's coming from the lateral horn. It's going to get into that spinal nerve, and this lighter blue is showing it as a myelinated or a white ramus fiber. It's going to synapse at this ganglia, which is a part of this sympathetic chain. And then from this ganglia, it's going to re-enter the spinal nerve, but this time it's doing so as a gray ramus fiber or as an unmyelinated fiber, and then it will head to the affected tissues. So in the darker blue, what we're seeing is that gray ramus or unmyelinated fiber there, okay? And then it'll go to those effector tissues. Okay, and this is pretty much just summarizing that as well. The second part of that, where it leaves the ganglia and heads to the effector tissue. It can also go to a collateral ganglia. Remember, not all of the fibers go to the sympathetic chain. Some of them go to ganglia which are not a part of the sympathetic chain, and they will do so in this exact same fashion. The preganglionic is myelinated, and the postganglionic is